Hi everyone, welcome to the second video on indices. So we're going to look at some more laws now and try and prove them and work out how they work. Okay, so we're going to look at this one here, which basically shows us what to do when we have a variable or letter raised to a power, which is then all being raised to another power. What we do is basically we multiply the indices together. Okay, so let's look at how this works, right? So if we've got, for example, x cubed, and then we square x cubed, okay? Think about what x cubed is for a minute. So x cubed is just x multiplied by x multiplied by x, right? And if we square that, we multiply it by itself. So squaring it, so yeah, we just multiply it by itself, okay? So that would give us x times x times x times x times x times x, which is just x to the power 6. Okay, how do we get to 6? Let's look at the rule, right? So we've got m and n and we multiply those together. So 3 and 2, we multiply those together and we get 6. Okay, so that's a kind of shortcut. So again, this section we don't really need to write out. We'll show you why. Okay, because if I have another example that says, say y to the power 4 and we raise that all to the power 6, then I'm not going to want to write out y times y times y times y 6 times, okay? Repeated 6 times. I'm just going to want to use the rule that says it's going to be y to the power 4 multiplied by 6, which is y to the power 24. Like so, okay? So, just to go over again, when we have a bracket and we're raising a variable raised to a power to another power, then we can multiply the indices together, giving us the new index when we simplify. Okay, again, we don't have to write this bit out. This is just to show you how it works. Okay, with a nice simple example. Right, moving on. Any number to the power 0 is equal to 1. Okay, so if you take your calculator, right? Let's try this. I'm going to switch it on. I'm going to put in any random number, and then we're going to raise that to the power 0. We get 1. Okay, so how does this work? Well, it's actually quite simple. If we think back to our division rule, so if we had x to the power 4 divided by x to the power 4, okay, then that would give us x to the power 0, right? Because we do 4 minus 4. This gives us 0. Now, we can cancel out the x to the power 4s from our knowledge of algebraic fractions, okay? But we need to remember something. We don't just get nothing, okay? This is 1x to the power 4 and 1x to the power 4. So 1 divided by 1 is just going to give us 1. Okay, so we can see that equals x to the power 0 by our index laws by subtracting 4 by 4, subtracting 4 and 4 gives us 0, so x to the power 0, but it also gives us 1 because we can cancel out the x to the power 4s from top and bottom, and we know that it's 1 times x to the power 4 for both of these, so the answer is going to be 1. Okay, and we're going to look at this one in a second, alright? Okay, so we're back after the bell, this time with this solution, so we'll kind of go back over this a little bit. So anything to the power 0 is 1. We can prove that through our subtraction rule, right, that we looked at the last time. So if we get x to the power 4, for x to the power 4, our subtraction rule says we're going to do 4 take away 4, which gives us x to the power 0. But also, which is really interesting, because we've got the same term in the top and the same term in the bottom, we can cancel both of these. And they both say 1x to the power 4. So, the 1's remain, which gives us 1 divided by 1, so the answer is 1. So these two things are equal. Okay? So then anything to the power anything to the power 0 is 1. Okay? Let's move on to this one here, right? And all we're saying here is that if we've got a negative power, we can make that a positive power on the denominator. Okay? And I'm going to show you how that one works as well. Right? So if we have x to the power 2 divided by x to the power 3. Okay, now our subtraction rule is going to tell us that's going to be x to the power 2 take away 3. And 2 take away 3, if you remember our negative numbers, is x to the power negative 1. But let's look at that from an algebraic fraction point of view as well. Okay, so if we look at x to the power 2 over x to the power 3, right, and we write that out in full, so what I mean by that is like this. Okay, so x squared over x cubed is going to be written down like this. Okay, and if I cancel everything down, right, so I've got this x will cancel with this one will cancel with this one, and remember if there's nothing on the top line, we can say that there's 1 there, and we can say that that's 1 over x, like that, okay? So let's look at an example with that just now. So I hope you get that, right? So it's like, you can see from our division rule, when we subtract the powers, we get negative 1, okay? And then we can also see if we expand that out, then we get 1 over x. So again, these two things are equal. And remember, this x by itself in the bottom has really got a power 1, okay? So that's quite interesting. Right, so let's look at an example, how we would actually work with this in practice. So, if we simplify just simply what we have, x to the power negative 4, and that's going to be equal to 1 over x to the power 4. It's really that simple, okay? So you can either kind of learn the reasons why the rules work, which are these here, okay, or you can basically just learn them kind of by rote and just say, well, if it's a negative power, I put 1 over the positive power. If it's to the power 0, I just put 1. Okay, so you can kind of do either or. We will explore this more in class, so we'll explore the reasons why this all works when we're in class, when I see you again there. Alright, but until then, if you can kind of just learn those and work with them, then that would be really, really good. Okay, so I hope you got everything that was in the video. Please rewind me, remember to subscribe to the YouTube channel, please, and I'll see you in class. Thanks.